Okay, now we will continue to talk about kinematic of particles. Previous class we talked about collinear motion in a 2D component, right? Let's recap some of the important concepts, right? So we talk about planar motion. We talk about when there is particles move in the curvilinear motion. If we want to study about that particles, we can look at tangent axis and normal axis. Tangent axis always help you to find the direction of your velocity, your acceleration, and so on. And then the normal component is pointing towards the center of the curve. Right? And the both U, T, and UN here, it represent direction. And don't confuse this one with velocity. Yeah? So this one is a vector direction. You know the vector have magnitude and direction. So the one that you're seeing here, U sub T, U sub N, this is the direction. Okay? Okay. Then we are talking about velocity. Velocity equal to U, UT. U is a magnitude. Direction we represent with the UT. For example, the one that I show you. All right? And the way we write differentiation is S with the dot above. Something with the dot above means that we differentiate over time to get that particular parameter. Okay, so start from this this section onwards. You need to recall your differentiation skill, and sometimes you need to recall your integration skill. All right. Acceleration give you this equation. This is what we covered previously. A equal to first derivative of first integration, first differential over your velocity. All right. You get acceleration, and this is the derivation from your U equation. U equal to V ut. V equal to V ut is a magnitude and direction. So when you differentiate two functions there, you will receive this one. Yeah. So previous lecture also I asked you to go home and find out the product rules. If you're not sure about what is product rules, how to differentiate the two functions together, recall back how you solve y equal to uv kind of question, right? And previous class we stopped at these slides. Okay, stop at these slides. So from a path, we can plot or we can draw or we can sketch the acceleration vector diagram. Each point will give you different direction. However, it follows some principle. For example, each point you always have a tangent direction and normal direction. In this point also, you have a tangent and normal direction. And since you have two vectors combined together, as you learn in the vector chapter, you can find the resultant using rectangular method. You combine two vectors together, you get the resultant. Same with this one. You have two vectors here. You combine this one with this one, or you can transfer. You can let me take my. You can transfer this one over here, right? You can take this one over here. Then you will see a triangular that you learn in vector. So this one plus this one equal to resultant. Okay, so this is how you find when you have a velocity, you have the acceleration. This is how you do. And this is a um, interesting logic where you have a particle that moves along the path. Okay, when you have a particle that moves along the path with the acceleration, magnitude, and direction along the path, then you only have one magnitude, which is A equal to tangent direction. Okay, this is just a reminder. Sometimes in test or exam, we just test you very simple concept, and you forget about this one. Okay? Just take note of this one. Huh? When your particles, the acceleration direction or velocity direction is along the path, then you only have tangent direction. In this case, today we talk about three-dimensional motion. Previous class we talked about 2D. What happens if you have a three-dimensional cases? Now previously we talked about the blue color path that the particles move on a plane like this one, right? Move on the plane and the particles is moving along this path, right? So when you talk about 3D, you need to consider one more direction, which is B. Previously, our tangent and normal is along this paper, right? On this paper. But when you consider three-dimensional case, what you do, you need to consider one more axis coming out from the paper. So in this case, as you can see from this diagram, you have your T and N on the plane, or the paper that I show you. So this plane, we give it a name, we call it osculating plane. Okay, osculating plane means the plane that your tangent and normal took place. And then when you talk about 3D, there's one more dimension come out from the plane, which is 90 degree from the plane. We label as B to represent this elevation of the plane. Okay, so from here you can see you have UT, UN, and UB. Today you have seen one more new things in our lecture. You are seeing UB with this additional dimension that added that become three-dimensional motion. And again, the both U here is not velocity, but is represent direction of your velocity. Okay, because your velocity is a vector. Vector have magnitude and direction. The both that you see here is the direction component. Okay, any questions so far? Any question?
Yes, sir.
Good, eh? Good, eh? Stop me if you're not able to understand anything that you see on the screen here. Right? So, still go back to the vector concept. Still go back to the vector concept. When you want to calculate the B vector direction, you can write UB. Again, this is direction. UB is not a velocity, but it's a direction for your velocity. UB equal to UT cross UN. Okay, this is a cross product. And T and T, your tangent and normal axis are 90 degree. Your B also 90 degree to B and O also 90 degree. B and T also 90 degree. That's why you can use cross products. Okay. Another way, since the three axis is always perpendicular to each other, right? Perpendicular to each other, you can use cross product for other component also. For example, you want to find you want to find n component, which is this one. How do you write the vector equation? You stand here, you stand at n axis, and then you're looking towards the b and t, right? So the equation will be un equal to ub cross ut. Imagine you standing here, and what do you see? You see b and t, so you can write ub cross ut. Back to the first equation. If you're standing, sorry, if you're standing at the b, if you're standing at the b axis, what do you see? You see now, you see n and t. That's why you can write ub equal ut cross product with un. Okay. So this is how you write, huh? How you write vector form. So when you do three-dimensional analysis, you need to consider the cross products for the direction. Okay, this is how you do when you have three axes that is perpendicular to each other. Okay, let's move on. I'm going to propose to you or suggest to you the procedure for analysis when it comes to cylindrical or tangential component for collinear motion. First, you look at your coordinate system like what we did previously. You look at your position, right? Look at your coordinate. Okay, where is the origin? Where is the normal and tangent axis? Okay, when you solve this kind of question, first copy the diagram, and then on the diagram that you draw in your answer, you draw two axes on the body. You draw normal and tangent axis on the object. Of course, you have to know your origin, right? The origin is from somewhere, and then you reach somewhere. Okay, first steps in your calculation, you look at where is your axis, two axes you focus on, normal and tangent. And of course, put in your origin as O. Sometimes in the question, the origin will give you as A, as B, as C. You need to follow along the question. Right? If the question gives you A as an origin, you should use A in your answer and not 0 in your answer. Okay. Next is the direction of your axis. Where is the positive direction? Where is yeah, that is important. Huh? So the direction that follow axis will be positive. For example, T, right? This direction, arrowhead will represent the positive direction. Huh? The T, if you're increasing your tangent direction in this way, means it is positive. Huh? It is positive. Same with the normal. Same with the normal. If you increase the distance from the particles, this is the positive direction of your hand. If you're going another way, you cannot no longer use positive, but you have to use a negative sign. First, we talk about coordinate system. Where is the axis? Which direction is positive? Which direction is negative? That is the first thing that we expect in the answer. Okay, so this is just an example. We'll give you a path. You copy the path from the question, and then mark the location of the object. Draw your tangent, normal, and the origin of your curve. Okay. And on the object itself, you draw the direction of your U, T, U, and the O of your origin of your object. Okay, so this is the first step that we expect in your answer. Any questions so far? Any question? Any one of you, you're not sure how to, what to do for your first step when you solve linear motion in a normal and tangential component. Of course, in test, final exam will help you, all right? Will help you to uh, do step by step. For example, the question will break into A, B, and C. So the A section, we will give some statements, something like sketch the motion of item showing your normal and tangential component in your diagram, something like that. So in your answer, we expect something like this. We expect your axis, the direction, and your origin. Of course, the path you can copy from the question. This is the first step. Second, you talk about velocity, right? Talk about velocity and remind yourself that velocity always tangent to the path. This is already covered previously. Huh? Velocity always tangent to your path. The magnitude of velocity is speed. Magnitude of velocity is speed. So how do you find speed? How do you find speed? You take the displacement equation, differentiate with time. Again, you need to recall differentiation scale. This is a first order differentiation. So you need to recall. It's just as an example, huh? So something like that. So first step, draw your position, draw your coordinate system. Second step, we expect you to draw the direction of the velocity vector. Vector have magnitude and direction. The direction always tangent to the curve. And because you have a curve, you will have a radius from the particles or from the item to the center of the curve. This is the second step. If the question asks you to solve velocity, it is the normal question that we will ask you to, after section A, we will ask you to sketch your coordinate system. B will ask you to solve velocity. C will ask you to solve acceleration. Okay. Okay. Tangent acceleration. You can read all this. This is the equation that we've seen before. AT is, you can write as the first derivative of your velocity, or you take velocity differentiate by time, you get acceleration. A sub t means in the tangent direction. And recall this equation for finding the acceleration in tangent direction. This one you recall. Sometimes you can solve with this equation. Sometimes you need to use this one and you integrate, you get the missing parameter using this equation. Okay, where to get this equation? Go back to the previous section when we talk about Newton motion equation. Okay, when we equal the dt of the acceleration and velocity is the same. If your tangent component is a constant, if this equation, your AT is a constant, you will arrive at the 3 Newton motion equation that we studied previously. Okay. Integrate one side, integrate the left hand side and right hand side, you arrive at these 3. Again, derivation we already discussed in the previous lecture. You can go back to the previous lecture video to review or to revise the concept. It is on AT, or acceleration in tangent direction. get three equations of Newton motion. Right? What are the normal? Okay, all this you can read in my slides. How to find the magnitude of a normal component for your acceleration. Also, we derive this equation in our previous lecture. We arrive at an equal v squared divided by radius. This rho represents the radius from the object to the center of the curve. Okay. So this diagram that we expect from your answer, after you draw the velocity, you need to further improve your schematic diagram. When there is an acceleration, means there's a change of velocity. We expect in your answer sheet there, you will sketch u t and u prime t in the answer. There's a change of location. There's a change of velocity. When there's a change of velocity, you can calculate acceleration. And because you are moving in the curvilinear motion or on the curve, there's a change of angle d theta from the center. If you stand at the center of the curve, you are labeled as O prime or O comma. You stand at there and you see the change of position. You can see actually there's a change of angle d theta. Okay. Again, remind yourself you have two important axes, which is tangent and normal axis. You can calculate the radius of your curve or the range from the center of your curvature to your object. You can use this equation, standard equation. We are not going back to the derivation how you get this one, right? It is more important you straight away use this equation to find the radius from the position to the origin. Not origin, but to the center of circle. Sorry. Okay. You look carefully at the structure of this operation. This is the radius, and you do the top, you do the bottom. You break it into two mathematical operations. On the top is bracket power 3 over 2 of something inside this bracket. Don't confuse with this. They will tend to import this one in. First derivative of your y equation, dy over dx. Again, you need to recall how to do differentiation. First order differentiation, and this component alone is power 2. Okay. Now let's say your y equal to 2x. Sorry. Now, y equal to 2x, for example. Dy dx equal to 2. Make sense? So 2 square. So 2, so you get 4, 4 plus 1, 5, and you calculate the exponential, 3 over 2. Look at the denominator. Denominator is d squared y divided by x squared 2. What does it mean? This is the second order differentiation, which means you differentiate 2 times of your y equation. For example, I use y equal to 2x just now. First order differentiation, you You differentiate dy dx, you get from y equal to 2x, you get 2. So when you get d square y divided by dx square, you get 0. So if you have a straight line equation, it is y equal to 2x, or linear equation, you have y equal to mx plus c. When you have a straight line, your rho will become something divided by 0. What do you get? What do you get? When you have a straight line, what do you get? I go back to the when you're moving in the straight line, y equal to mx plus c linear equation. If you calculate that, if you this particular move in a straight line, and you want to calculate the radius, the radius is too big. There's no center point for straight line. Okay. Now, but for collinear motion, you will always have the quadratic equation and above. It means you get quadratic equation. The more complex case will give you polynomial equation. It is x power n and so on. It allows you to do differentiation procedure. Okay. Again, back to your mathematics chapter. If you're not very good with differentiation, this is the first differentiation, this is the second differentiation. Now let's say you have y equal to x squared. You have a quadratic motion. It is you have a curvature motion, a curvature path. When you have y equal to x squared, dy dx, what do you get? Let me test the class. Hilton, are you there? Let me check the attendance. Hilton, are you there? Calling Hilton. Calling Hilton first time. Calling Hilton second time. Calling Hilton third time. Let me text Hilton in the group. Let me give Hilton a warning. Okay, Hilton consider not in the class. Let me ask another question. Stephen, are you in the class?
Yes, sir.
Okay, Stephen, if you have a path that is quadratic equation, y equal to x squared, when you do dy dx, what do you get?
Can you repeat that? I couldn't hear you clearly.
When you have a path in the quadratic motion, y equal to x squared. What is the equation that I just give you, Stephen?
I'm not sure, sir.
When you have a quadratic equation, I give you an equation y equal to x squared. What is the equation that I just give you? You can't hear me clearly, or you don't know what I'm saying?
It should be a curve.
again, Newton, what do you say just now?
It's a curve.
It's not clear.
It is a curve.
Yeah, it's a curve. So you are having a what equation that I just mentioned just now? Y equal to what?
X squared.
Okay, x equal to x squared. When you do dy dx, what is the answer?
2x.
Correct. When you do d square y over dx square, what do you get, Stephen?
2.
Correct. So you have, let's say you have a curve with y equal to x squared, dy dx, you get 2x. Second order differentiation, you get 2. So you substitute 1 over 2x here, 2 over here. Then you can solve this equation. How do you get the x location? You will be given exact location of your x and y on the curve, right? This is how you solve for your radius. Very good, Stephen. Very good. Okay, let's have a short break. Let me end the recording.
Sorry, sir. The X location is based